All right, this video is going to cover the 2016 official AP Calculus AB practice exam. This is number 3, and number 3 refers to a graph. Now, I've gone ahead and drawn out a rough sketch of it on my whiteboard here that I'll refer to, but it's a graph of G. And it's also, it says that it is a graph, it says f of x is equal to from negative a to x of g of t dt. So from the fundamental theorem of calculus, f prime of x, you want to plug in the upper limit and then multiply by the derivative of the upper limit, which is just 1. So f prime of x is equal to g of x. So not only is this a graph of g, it's a graph of f prime. Now, later on in the question, you're going to need to know the areas under the curve. So I went ahead and wrote those in red. So you've got this triangle here between negative 8 and negative 6. 1/2 base times height would give you 2. And since it's below the axis, we'll make that a negative 2. This triangle's the same size, but it's above the axis, so it's a positive 2. So go ahead on your paper and draw these in. And then we have a rectangle here between negative 4 and 0 with a height of 2, so that area would be 8. And then we have a semicircle above that. Circle is pi r squared. The radius is 4. So this would be a semicircle, not even a quarter of a circle is what it is, not a semicircle. So it would be pi r squared over 4. So that'd be 16 pi over 4, which reduces to 4 pi. So write those in on your graph. We'll be referring back to those. Part A says find all the values of x in the interval between negative 8 and 6. Okay, so the whole thing. Where f has a critical point, and is that a local minimum, a maximum, or neither, and you have to justify your answers. Well, critical points occur where f prime is equal to 0. So the first one occurs here at negative 6. You have another one at 2. But you don't count this one at 6 because it doesn't go past 6. The graph ends right there. So that's an end point. So it's not a critical point. All right, so our critical points occur at x is equal to negative 6 and 2. Maxes or mins occur when f prime goes from negative to positive. So a min occurs at x equals negative 6 because f prime goes from negative to positive. So you'll want to write that out on the 2020 test. Write out your explanation, and then you have a max at x equals 2 because f prime goes from positive to negative. If you remember your sign lines from chapter 3 when we looked at that kind of stuff. Okay, so that answers part A. It's an easy one. The only thing you don't want to confuse is that 6 here is an endpoint, so it's not a critical point. So don't pick that. All right, I'm going to erase and we'll move on to B, C, and D. Okay, part B says find f of 0. Now this is a fundamental theorem of calculus. F of 0 is equal to, and what you do is you use this. You integrate from negative 8 to 0, put the 0 right there, of g of t dt. And so what we need to do is find the area under the curve from -8 to 0. Okay, so that makes it pretty easy because we don't have to flip these. This already goes from a lesser to greater. So if it were opposite, if it was 0 to -8, we would have to flip it by making it negative out front. Okay, so the area under the curve from there, it's going to be -2, right, that triangle, plus 2, plus 8, plus 4 pi. So those two cancel and you get 8 plus 4 pi. So that one was really straightforward. We didn't have to reverse the limits of integration and make it negative. It was really a straightforward one. So hopefully if you get one on the 2020 test, it'll be pretty straightforward like that. Okay, so let's see if we can do part C. Part C says find the limit as x approaches -4 of f of x over x squared plus 4x. Now I don't need the graph anymore. Actually I do. I better not erase that. Okay, I need it for part D. So I'm going to try to squeeze part C in here. Let's use L'Hopital's rule. And remember, you have to do an LH, okay, to signify L'Hopital's rule. So it's the limit as x approaches -4 of, you have to take the derivative of the top, that's f prime of x, over 2x plus 4, taking the derivative of the bottom. Okay, so what is, this would be f prime of -4 over 2 times -4 plus 4. Well, what is f prime of -4? Okay, well, it's 2, right? 1, 2, 3, 4. -4, 2. The answer would be 2. So that's going to be, since f prime of -4 is 2, just read the graph. So from graph, all right, and then 2 times -4 plus 4. That'd be -8 plus 4, -4. So that's -1/2. So this one, because you know the values of f prime, as long as you use L'Hopital's rule, you can just read from the graph and then plug in -4. Pretty easy. Okay, so pause it if you need to. And we'll do part D. Part D says h of x is equal to g of x over x squared plus 1. We want to find h prime of 1. Okay, well, h prime of x, this is a quotient rule. So it's the bottom, x squared plus 1, times the derivative of the top, g prime of x, minus the top, g of x, times the derivative of the bottom, 2x, all over the bottom squared. Okay, we need to figure out a couple things before we plug in. First of all, we need to figure out g prime of 1. Well, that's going to be the slope, since this is a graph of g, the slope at x equals 1. All right, so that's this slope right here. Okay, so what you could do if you wanted, on that one is just, you know, pick a couple of points and figure out the slope. So it's the change in y over the change in x. So that would be 0. In fact, sorry, I wrote that wrong. That's 0, 6. So that's going to be 0 minus 6 over 2 minus 0. So that's negative 3. So g prime of 1 is going to be negative 3. And then how about g of 1? Because we need that for g of x. G of 1, all right? Well, when g is 1, when x is 1, y is 3. Remember, this is, we don't have to figure out the slope. This is a graph of g, so just read from graph. So graph at x equals 1. So g of 1 is going to be equal to 3. So now we plug those numbers in. So h prime of 1, okay, is equal to 1 squared plus 1 times negative 3, g prime of 1, minus 3 times 2 times 1, okay, because 2 times 1 right there, and then g of x is 3, over 1 squared plus 1 squared. All right, so this right here squared, so that's going to be 2 squared. Okay, so that's going to be negative 6 minus 6 over 4, negative 12 over 4, negative 3. Right, I just want to, and that is the correct answer. So this problem is a great one to study. It absolutely could be on the 2020 test. All 4 parts are fair game. I would be not surprised at all if on the 2020 test you had to work a problem like this. Okay, so that's it for this video. I don't want to, I just want, this problem was so important I wanted to just leave it by itself on a video. So I'll work number 4 on the next video, and we will talk to you then.